Alright, so this is section 5.6, which is on small sample confidence intervals for the difference between two means. So now suppose we have two small samples, x1, x2, all the way to x and x, and y1, y2, all the way to y and y. And these are small samples, which means the sample size is less than 30, and they are independent. And because we're talking about small samples, so we need to assume they are from a normal distribution. Okay, then we can construct 100 times 1 minus alpha % confidence interval for the difference of population means. So the center is the difference of sample means, and we have the square root of the variance added together. And before that, instead of having the z alpha over 2, we have t with degree of freedom nu and alpha over 2. The degree of freedom here is really complicated, so let me write it separately. Degree of freedom. Okay. So the degree of freedom is given by this formula. I'm just going to write it down. It's fairly complicated. And round it down. So here's a big warning. So if you use GeoGebra doesn't really round down the degree of freedom. So the answer if you use GeoGebra will be different. So make sure you round down and use the table, and then use the t table. All right, so let's do an example here. Okay, so let's assume men's height and woman's height are independently distributed. Independently, normally distributed. And then let's sample 10 men. So their heights are 169, 189, 188, 194, 177, 187, 172, 168, 181, 183. And let's sample 9 women. So it's 171, 166, 173, 162, 163, 158, 164, 158, 162. All these are in centimeters. So before we calculate the confidence interval, we need to calculate the degree of freedom. So let me copy down this complicated formula here. It's a little different. Whole thing square over nx minus 1 plus sy squared over ny. Whole thing square over ny minus 1. Round it down. Okay. So we need certain values before we calculate this degree of freedom. So x has sample size 10. The sample mean, if you use the calculator, is 180.8. And the sample standard deviation is 9.016. For y, sample size is 9. Sample mean is 164.11. And the sample standard deviation is 5.183. So now we can plug in the sample sizes and the sample standard deviations into nu and calculate the degree of freedom. So plugging everything, this is equal to 14.607. Remember, we round down, so it's 14. So a 95% confidence interval for the difference of population means is x bar minus y bar plus minus t. Degree of freedom is 14. 95%, so it's 0.025 times the square root of the variance. And everything can be found somewhere. So this, we can use the t-table. This is equal to 2.145. And all the other values are just right above there. So we can use calculator this to get this is equal to 1.16.69 plus minus 7.151 centimeters.